We often talk about programming careers, and we even have a few series here on the channel about different programming languages. But today we're going to shift gears just a little bit and talk about which programming languages make sense for you to learn. Stick around. Hey everyone, welcome back to Today in Tech. I'm Juliette Beauchamp, and I'm here with Serdar Yegulalp, a senior writer for InfoWorld. Thank you so much, Serdar, for calling in and joining me today.
Well, good to be here.
And some of you may recognize Serdar, of course, from the other videos that we've done together here on the channel. But importantly, he hosts two programming language how-to series about Python and Go language. So we'll link those below so you can check them out. But Serdar, I'm hoping you can start us off by just going over what, the most popular programming languages are, just to provide a brief overview of what we're going to be discussing today.
Well, I want to preface all this by saying that I'm probably going to be a little bit biased because two of the languages that I cover in my video series are going to be two that I mentioned. And that's a big part of why they cover them, because they're so popular. And the first one that comes to mind is the one that I cover most aggressively, which is Python. And that has skyrocketed to the top of the popularity lists in terms of what programming languages are currently in use, in big part because of its ease of use and its convenience. These are all things I'll go into a little bit later. So Python is definitely tops on the list. But others on the list are languages that have been around for quite some time and have proven themselves to be stayers. Java, for instance, and more recently, its freshly minted cousin Kotlin. Java should be a very familiar name to a lot of people listening here, so it's probably no surprise that it turns up regularly in the list of what's popular to learn. And also languages that are even older than Java that have stuck around and proven themselves to be powerful and worthwhile simply because they do things that really are kind of hard to find anywhere else. And I'm thinking specifically of C and C++. When you need control over the machine that you're running the software on, and when you need speed at its absolute, those are two of the ones that you pick the most. And more recently, we've seen the emergence of new languages that are aimed at the enterprise and also at machine level work. And the first of those is the Go language, originally developed by folks at Google, although it's now developed by a much larger consortium of people. And the other is the Rust language, originally developed by folks at Mozilla. But again, it's sort of taken off and become its own thing apart from those the browser developer company. So those are five right there that are popular: Python, Java, C, C++, Go, and Rust.
So I'd like to dive a little bit more into, the who of it all, right? And I'm sure our viewers watching are curious about which programming languages make the most sense for them to learn, like we already mentioned. So I'm hoping that you can sort of take us through, I know it's a lot of programming languages, about who is most suited to learn those languages, what types of jobs and job descriptions would be that would make the most sense to learn, Python, for example, and the use cases for each of those languages.
Well, one of the most common use cases that we come across is just something where we would need to build the logic for a generic business application. And that's one of the areas where Java has become a pretty standard standby, and simply because it's been used in that function for so long, and because there are so many third-party additions available with a language that allow building those sorts of things readily. But Go has recently emerged as another language for that use case, where you want to build things that are either customer facing or that are both customer and internal user facing, and where you want to develop quickly and where you want to develop efficiently. Java has a little bit of an advantage there, and that it's been around for a long time and that a lot of people know how to use it, but Go has a slight advantage in terms of it being a little faster to work in. The one that's fastest of all to work in, of all of them, is Python, and that's one of the reasons I keep coming back to it as a recommendation. It is very easy to stand something up in Python and get it running, and so if you need something built on fairly short order, that's one of the first languages to reach for. And so it's useful for things like enterprise applications, and also for a close brother to those types of work, namely things that power the back end of a website. So Python and Go and Java tend to be useful for those things. But one of the other areas that I've seen Python taking off in is the area of machine learning and data science. And these are, very buzzwordy types of things. And so people are always not quite sure, what the advantages that Python brings there. And its big advantage is, again, this convenience of use. That if you want to get answers and you want to get insight into data and you want to generate predictions and you want to do all of those things with relatively little code, Python winds up becoming one of the big go-tos for that sort of thing, because you can put things together in a few dozen lines of code that would otherwise be much more sprawling and unwieldy in other languages. And then there are times when you have to write software that deals with the machine directly. When you have to write a device driver, or you have to write something that has extremely fine-grained control over memory for the sake of speed, for the sake of efficiency. This is where C and C++ come in. These languages have been around for decades, and they have a very strong story when it comes to writing software that runs fast. The downside is that they are also very easy to shoot yourself in the foot with. When you have full control over memory, that means that every single mistake that you could make is amplified 100-fold. And so that's where Rust comes in. Rust is a relatively new language that was designed in many ways to take over where C and C++ left off, especially in terms of how things like memory are managed. If a program does not manage memory correctly in Rust, it simply won't compile. That's the general idea. And so while there is a much sharper learning curve with something like Rust than there is with something like Python, the end result is you have a much faster program, and you also have that much more secure and stable a program, especially in terms of memory management. So those are the kinds of scenarios that you would see for each of these. And by the way, I don't want to imply that writing something in Python or Go doesn't have good memory management. It's just that the fine-grained details of how to do that are out of reach for you deliberately, by design. So a lot of it also revolves around questions of, how much control do I really want in this particular application? How much am I going to need?
Yeah. So it seems like you mentioned, each of these languages have their own use cases in which they're best suited to. So, for example, to just recap what we've said, it seems like for some of the back-end web development kind of sorts of things, it seems like Python and Go are best suited for that. Yeah. And data science, what should data scientists be looking, or aspiring data scientists be looking to learn?
Well, Python, obviously, and also the collection of packages that go with Python that make working with data science easier and faster. Python by itself is not a very fast language. It's fast enough for most work. But when it comes to serious number crunching, it's not very fast. And so these additional packages, some of which are written in C or C++ or Rust, provide a convenience wrapper around them made out of Python, so that you are in effect commanding and controlling software written in C, C++, et cetera, through Python as a way to get this terrific speed and all the conveniences that you would need to perform, data research without having to compromise.
Sure. And just referencing my handy list that I have here, it looks like general enterprise applications, Java and Go. When it comes to something, speed and any sort of demanding application, that's C or C++ and Rust. And for mobile development, Java and Kotlin. Do you think we covered all the bases there?
Pretty much. As far as Kotlin goes, by the way, one of the things about Java is that the language by itself is written on top of a substrate, as it were, called the JVM, or the Java Virtual Machine. And the JVM is language neutral. Java isn't the only thing that can run on top of it. Kotlin was developed recently as another language that can run on the JVM, and which is actually a lot easier to program in than Java for many use cases. And many of the developers on Android have started turning to Kotlin as a good way to produce mobile apps quickly and conveniently without having to deal with a lot of Java's boilerplate. So that's another case where Java becomes very useful, is if you're doing mobile development on Android. If you're doing mobile development on iOS, at this point, it's basically the Swift language. And that's pretty much something that Apple developers contend with almost exclusively. It hasn't really moved beyond that into other realms, at least not yet.
I'm wondering, too, if there's any sort of natural progression when it comes to learning programming languages that perhaps our viewers can benefit from. For example, if it's more helpful to learn, X language now, and that will help you learn Y language in the future, what is the sort of the natural progression of programming languages or learning programming languages? Or if there isn't a natural progression, what would you at least recommend?
Again, I'm going to be really biased here, and I'm going to say If you start with Python, it's really hard to go wrong, in big part because it's an extraordinarily easy language to get up and running with, and to pick up. There isn't very much in the way of complexity outwardly. It's designed to be easy to read and easy to work with, without also sacrificing power further on down the line, except in the sense that it doesn't run quite as fast as some of the other languages. But it's very expressive, and it allows you to jump in and just get things done right away. And for a lot of people, it gives them a great sense of achievement. But the other thing about having that nice low a barrier to entry is that it's not just about learning the language. It's also about learning the techniques and the tricks of the trade that are associated with software development. If you start with an easy language like Python, you're not constantly struggling with it, then you have that much more headspace to deal with all of the other things that are important when learning how to develop software. You learn how to do things like manage revisions between versions of an application. You learn how to manage your workspace and how to manage the modularization of the program itself. Now, these are all things that are perfectly possible to learn if you're also starting somewhere else. If you start with Go, or if you start with Java, or if you start with C or C++, or if you start with Rust, all of those things can be learned there too. But my personal bias is that if you start with Python, you're going to have less conceptual complexity getting in the way of just learning the language and learning how to get results immediately. And then you have more space in your mind for learning how to deal with all of the other things that go with developing. To be deadly honest about it, though, we've reached a point where it's actually really hard to go wrong by picking any one of the big popular languages, because the resources that we have available now, as opposed to even 10 years ago, are absolutely amazing. It's really astonishing how rich and vibrant a culture of learning we have around pretty much all of the major programming languages. But again, I remain consistently impressed with what's available for Python, in big part because the ease of learning for the language generally also makes that's also driven an even more vibrant culture of learning around the language. But again, whatever you start with, it's really just a basis for learning how to learn. Once you've learned one programming language and you've learned the techniques for navigating a language's documentation and learning how to deal with its quirks, that gives you a foundation that you can apply anywhere.
Frankly, just like learning any other language.
Exactly. Once you've learned how to speak French, other Romance languages also tend to come that much more readily. You learn German and other languages that are based on it. Although I think, last that I recall, there aren't that many that are currently based on it and currently in use anymore. But you get the idea. They give you skills that are outwardly portable. And my own bias being towards Python, just because it's so much easier to get started than with many other places.
Sure. And I think, the final question for all of our viewers would probably be, where does one even go to begin to learn these programming languages? Obviously, we can plug ourselves here a little bit and plug you and direct our viewers to your Python and Go series. But what are some other, next steps for anyone who's hoping to learn a little bit more about any of these languages?
Well, any of the big code academies and boot camps at this point have courses, and they are often a good way to drop in and just start swimming. As far as Python goes, obviously there's my own video course, but I've also discovered, there's my course and there's also the regular series of articles that I produce, but there's also a very good site called Real Python that has a lot of excellent and highly specific and detailed examples for all of the different capacities in the language. And many of the newer languages actually have excellent learning facilities right on the language's website. Go and Rust both, for instance, have their own educational material available directly side by side along with the reference material. And in both cases, you can actually get live feedback on your code. You can actually run the code directly in the browser and see its results. So you don't even necessarily have to download anything to get started. You can start experimenting right away.
Awesome. Well, thank you so much, Serdar. And of course, for all of our viewers who are interested in learning more about Python and Go, we will link not only Serdar's video series below, but also his article series on InfoWorld. So you can dive in, get your toes wet, get your feet wet, and really learn more, because it's going to be useful no matter, what sort of IT or business career you pursue. So thank you so much, Serdar. I really appreciate it. And thank you all so much for watching this episode of Today in Tech. If you liked this video, be sure to give it a thumbs up and subscribe to our channel and hit the bell icon in the corner so you're notified every single time we post a new video. If you have any questions, comments, or better yet, resources for learning any of these languages, or if you've been through it and you're a seasoned programmer or software developer and you'd like to comment and let us know what your journey has been, perhaps offer tips to anyone who's looking to be in your shoes one day, let us know in the comments. Thanks again for watching, and I'll see you next time.